morning, Philippines! Maayong buntag, Mindanao ug mabulahanong adlaw, Rion Diaz. I am excited to share something new today. I am Teacher Aliyah Acobo of Loot National High School, Salay District, Division of Misamis Oriental, your partner in learning grade 10 science. Students, stay seated and let us all be awed with the wonders of the beautiful world we live in. The Earth's whole lithosphere is broken into several rigid sections called plates that move constantly. Do these lithospheric plates move quickly or slowly? What must be the reason behind the motion of the massive lithospheric plates? After going through this video lesson, you should be able to lesson contains different activities that will help you understand the driving force behind plate tectonics. Before we explore the wonders of tectonic plates, let us get your brains working. This will help yourself know how knowledgeable you are with the topic. You will answer questions flashed on the screen and you'll only be given 10 seconds to answer each question. Do not worry, because at the end of this lesson, you will be able to learn more. Are you all ready? Let's explore now.
Lithospheric plates are slowly moving at different directions. This movement of plates can be classified into three types of plate boundaries, namely convergent plate boundary, divergent plate boundary, and transform fault plate boundary. Along the plate margins, earthquakes, volcanoes, and mountain ranges are being formed.
So, how's the video? Well, in this lesson, you will learn the mental convection and forces as mechanism to the motion of massive plates of the lithosphere and the development of the theory of plate tectonics. Let us start our lesson with an activity entitled Convection in the Mental Vocabulary. Congratulations! You did well! To deepen your understanding about our lesson today, let us watch this video.
Are you sure this thing is rated for this depth? You bought it from an Air Mall catalog. Oh, great. Dear Tim and Moby, when I look at a map, it seems like some continents fit together perfectly. Are my eyes playing tricks on me? From Georgia. You're not seeing things, Georgia. Some continents look exactly like puzzle pieces that snap together. Early map makers suspected that they were once all connected. In the early 20th century, a scientist named Alfred Wegener called this supercontinent Pangaea. He thought different chunks of it broke off and slowly moved apart. Over millions of years, they formed the continents we know today. Wegener couldn't explain why Pangaea split up or how. But there was some evidence to support his idea. Fossils from similar plants and animals had been found oceans apart. The age and type of rock layers matched up too. Wegener's theory of continental drift provided an explanation, but his ideas weren't taken seriously until long after he died. In the 1950s, scientists began mapping the Mid-Atlantic Ridge. It's a mountain range running 10,000 miles along the ocean floor. tests revealed that the farther you got from the ridge, the older the seafloor was. So a geologist named Harry Hess proposed a revolutionary idea. New seafloor was forming at the ridge and spreading outward to make room for more. In other words, the surface of the planet was moving. Hess called this process seafloor spreading. It seemed to indicate that rock was being forced up from inside the planet. Nowadays, we can see this rock formation in action. Wegener had guessed something like this, but he had no way to prove it at the time. As he suspected, there's a lot going on beneath the Earth's surface. Up here, everything seems pretty cool and stable. But miles below our feet, it's a raging inferno. The deeper you go, the hotter it gets. Earth's center, or core, is as scorching as the surface of the sun. All that energy wants to escape, like steam inside a boiling kettle. It pushes outward, putting immense pressure on the middle section, the mantle. Standing in its way is the lithosphere, a rigid layer of solid rock. Well, the lithosphere isn't like a smooth shell. It's cracked into pieces, each one a different shape, size, and thickness. We call those pieces plates. Yep, the Mid-Atlantic Ridge is the border between several plates. They're being dragged apart by forces from deep inside the planet. You can think of it like a pot of soup. The Earth's core is the burner, and the mantle is the boiling soup. As the soup near the burner heats up, it becomes less dense and rises. When it gets to the top, it cools off and sinks down toward the heat. In physics, those are called convection currents. A similar process is driving the mantle, and it's taking the plates along for the ride. That movement is called plate tectonics. It's the engine driving the constant transformation of our planet's surface. Plates have been bouncing off each other for eons. The oceans have expanded and contracted. Land masses have smashed into each other and broken apart. The plates move about as fast as your fingernails grow, so we don't see the ground sliding around under our feet, but we do sometimes feel it. Yep, I'm talking about earthquakes. Seismic activity is greatest along plate borders. At convergent boundaries where two plates collide, at divergent boundaries where they pull apart, and at transform boundaries where they slide past each other. At all three boundaries, there's enormous pressure on the Earth's crust. That's the topmost layer of the lithosphere. The pressure can build up for years. The longer it takes to release, the bigger the earthquake. Yep, and plate movement drives volcanic activity too. At divergent boundaries like the Mid-Atlantic Ridge, there's a gap in the lithosphere. So magma, molten rock from the mantle, is constantly pushing up along the boundaries. These are the most volcanically active places on Earth. What do you mean, out of juice? We're stuck here? Ah! Now what? Oh, thank you.
Did you enjoy the plate tectonic exploration in our lesson today? Amazing, isn't it? We cannot imagine how the world works its wonders. Before we end our lesson, why don't we summarize the things that you have learned by doing the Let's Do the Sum Up Challenge. attentively, then you aced it. This time, let us test your ability by answering these questions. You will only be given 10 seconds to answer each of the question. Write your answers on a 1F crosswise. After answering, insert it to your science envelope and do not forget to submit it to your science 10 teacher during the designated date and time of module retrieval.